Hello people, in this video we want to look at intraocular lens. So in the exam they can ask you the definition of intraocular lens, the types of intraocular lens, the advantages, the lens power calculations they have asked the materials used in manufacturing. Okay, all this they can ask. It's also called as IOL, intraocular lens. So this is a intraocular lens. This is how it looks. So where does it exactly fit, guys? In the eye. Very good. So here you can see this is the light coming in. This is the cornea. Here you have your iris, and behind it they have kept the intraocular lens. So if this is not there, what exactly had to be here? Actually in this place there had to be our crystalline lens, right? So that crystalline lens they have removed for some reason. Aphakia has been either because of cataract or something, they have removed the crystalline lens, right? And they have put an artificial lens. So it is a method of correcting aphakia. So if there is no lens, okay, you will have lens in your eye. If that lens is not there for some reason, mostly it will be surgical correction, that will become aphakia. Now they will put an intraocular lens. Once they put an intraocular lens, it will become what? Pseudophakia. Okay, fake is lens. So first you will be phakia, then they will remove it, it will become aphakia, then they will put an IOL, it will become pseudophakia. In 1949, a British ophthalmologist, Harold Ridley, he is the person who first performed this. Okay, since then they have been trying it, and that's what they're saying. So you got what IOL is. Look at the advantages of IOL over spectacle for aphakia. See what happens when you give spectacles. When there is no lens inside the eye, you will have to give very high power spectacles. So there will be a lot of magnification, okay, with the spectacles, and there can be anisometropia, right? Especially for one, if there's unilateral aphakia, right? Then they will have one spectacles which is very, very high powered. So that can cause anisometropia, etc. So there can be aberrations, prismatic effect with thick glasses, etc. So now what they are doing, they're putting this lens where instead of giving a spectacles, they're putting the lens inside the eye. So all these are the advantages. There will be no magnification of the object. There is no problem of anisometropia. There is no aberration. There is no prismatic effect. There is wider and better field of vision. Cosmetically, it is more acceptable, yes, because something is inside the eye, it is not visible, right? So what is it? It's better than spectacles, okay? Especially because for aphakia, when there is no lens, you'll have to put a very thick, high-powered spectacles, and that too, if it is unilateral, they will have a lot of issues of magnification, anisometropia, aberrations, prismatic effect, etc. So IOL is better than wearing thick glasses. Remember, the magnification will be very high if you wear spectacles, okay? Okay, now let us go, that magnification will not be good, right? You just want to see, you don't want it magnified, right? Okay. So pseudophakia, we told you, when there is presence of intraocular lens in the papillary area, right? What is the refractive position of pseudophakic eye? What is this refractive position? It may become emetropic, that means it can become perfect, whatever they want, 6/6, or they can become myopic or hypometropic, depending on the power of the IOL implant. Basically, what do we want to do? We want to make it emetropic, right? We want them to have perfect vision. Look at this. This is a intraocular lens. Look at the parts. The center part, clear lens is an lens part is an optic. It's called as an optic, and these arms are called as haptic. Okay, these are haptics and these are optics. Optic. There's one optic here and two haptics. Okay, what is the average standard power of posterior chamber IOL? So if you are putting the IOL in the place of the crystalline lens into the capsule of the lens, what is the average standard power? How will you calculate? All that is important. So you will have to calculate it. Calculation will come, okay? They are using some calculated biometry using a keratometer. So we'll have to calculate this. Just hold on to the calculation part. What is the average weight of an IOL? The average weight of IOL is 15 milligram in air, and in aqueous humor it will be around 5 milligram, okay? 5 milligram inside the eye. In the air, if you hold in your hand, 15 milligram. Okay. What is the power of IOL in air vis-a-vis in the aqueous humor? Just now is okay. This is the power. They're asking about the power in the air versus the power in the aqueous humor. The power of IOL in air is much more. Remember, in the air, its power will be more, about 60 plus 60 diopter, but once it goes into water, that is aqueous humor kind of a material, right, water kind of material, the power is reducing, see, plus 20 diopter. You want to achieve what? Around less than 20 only you want to achieve, right? That is the power of the crystalline lens. Okay. So where is the IOL being placed? The IOL, see, they'll remove this lens, right? And they will place a IOL here. This is a posterior chamber lens, okay? They can also place it here in anterior chamber. So that will become an anterior chamber lens. So if it is anterior, what will happen to the power? Anterior chamber, they'll put little less power than the posterior chamber. Remember, posterior chamber, you need around plus 20 diopter. What are the indications for IOL implantation? Each and every case being operated for cataract, they are trying to put IOL unless it is contraindicated, okay? Guys, now we had just looked at small introduction. Now let us look at types of intraocular lens. Remember, you already know anterior chamber lens, posterior chamber lens. You heard about that. There is iris supported lens also. Okay. So anterior chamber, iris supported and all not very common. What you have to know is posterior chamber lens. These are very common. Okay. For anterior chamber, it is also called as angle supported. There is some example here. Kelman, if you want to remember, you can remember. Iris supported lens, you have Singh and Worst iris claw lens. Okay. Then depending on the material, you have rigid IOL, foldable IOL, rollable IOL. You should know these: rigid, foldable, rollable. So if it is rigid, you need a bigger opening to put it in. Foldable, so you can fold it and put it inside through a small incision. Rollable means even more very tiny incision you can put the IOL. Remember, rigid is made out of this material PMMA. Rigid IOL is made from PMMA. What is PMMA? It's polymethyl methacrylate, like that, you remember. Foldable will be silicone, acrylic, hydrogel, Kelman. Is it? We'll just remember silicone, acrylic, hydrogel, all this we'll remember. Kelman, what's Kelman? Then you have rollable. Let's look at rollable now. Rollable ultra thin, these are ultra thin IOLs. These are implanted through 1 millimeter incision. Just 1 millimeter incision is enough to remember. Micro incision, cataract surgery. This is made up of hydrogel. So blue color is perfectly fitting for it. Guys, what did you understand? Rigid, foldable, and what is the third one? Rollable. Yes. See, for rigid, PMMA, foldable, silicone, acrylic, you remember. Hydrogel, we will remember for the third one. See here, the incision is around 3 millimeter for foldable. Okay. And for rollable, just 1 millimeter incision after micro cataract surgery. Micro incision cataract surgery, just 1 millimeter. They will put a rollable IOL. These are made up of hydrogel. Are you understanding, guys? Is it going over your head? Let's continue. So actually, we are looking at the types of intraocular lens. In that we have finished based on the method of fixation, where the location kind of a thing. Depending on the material we saw, now let us look at that based on the focusing ability of the IOLs. You have unifocal, multifocal, accommodative. This is unifocal, guys. It will have single power. Look at this one here. This is multifocal. So it has near vision, distance vision. So different, it is multifocal. This is accommodative. Even accommodation can happen with this crystal lens. But these are very difficult to get adjusted to, multifocal and all these complicated ones. There is something here now in types of intraocular lens. Aphakic versus phakic refractive IOLs. What does that mean? Aphakic IOLs means which are implanted when there is no lens, right? But what is special phakic IOLs? That means the lens is still there and they want to correct the refractive error. So this is called implantable Kelman lens. Okay, and there are some details. So if a person has myopia greater than 8 diopter, a special type of intraocular lens is implanted in the anterior chamber, okay, or the posterior chamber anterior to the natural crystalline lens. So with the natural lens, they are putting an artificial lens. Okay, if the myopia is greater than 8 diopter. So people, what are we looking at? Types of intraocular lens. We are done till here, right? Now let us look at the last one, special function IOLs. So what special function will these do other than correcting aphakia? These are Toric IOLs correcting astigmatism. So Toric IOLs correct what? Astigmatism. Aspheric IOLs. These will reduce some spherical aberration. Aspheric. Aniridia. These are cosmetically cover the defects of aniridia or partial iris loss in cases like trauma. So this is some beautification purpose they are giving. Aniridia means no iris or what? Look at this image. This guy has no iris. Interesting. Wow. That must be causing a lot of photophobia. What do you think? So there are so many types of special function IOLs. Let us look at the images here from the textbook. Special function IOLs, you have toric. So this is toric. How to know it is toric? It should be correcting astigmatism. And Aniridia IOL, that is to, oh, see, look at this. It looks like there's a pupil, just cosmetic purpose. And here, I mean, it looks like there's an iris. So this will be the iris and this will be the pupil. Okay. We are done with the types of intraocular lens. So in the exam, if they ask you types of intraocular lens, what and all will you write? Anterior, iris, posterior, unifocal, multifocal, accommodative, then toric, then aspheric, then aniridia, then aphakia versus phakic, refractive, then rigid, foldable, rollable. Please don't forget. So many. 1, 2, 3, 4, 5. 5 types of classifications. Okay, let's move on now. See if you can guess what this is. Where is the lens in this? Anterior chamber lens. Not very popular. Example, Kelman. Very good. This one. Iris supported lens. Not very popular. Okay. This one. Oh, you already saw this. Posterior chamber lens. This has so many things. Okay. In this itself, there are so many types. Intra in the capsule. Ciliary sulcus fixation. Scleral fixation. Retro iris fixation. In this, actually, they are taking the iris claw lens and putting it in the posterior chamber. So in the posterior chamber, which they actually do, you have in the capsule, then in ciliary sulcus fixation, scleral fixation, retro iris fixation. So many types are there in posterior. Okay. Now shall we calculate the power of IOL? Okay. So here, how will you calculate the power of posterior chamber IOL that has to be implanted? So what did they tell you? Some biometry, keratometry you should do, right? A scan ultrasound you have to use. So you have to calculate by, okay. SRK formula. What is this? SRK formula is commonly employed to calculate the IOL power. Power is equal to A minus 2.5 L minus 0.9 K. Wow. So this formula, if you remember, you will get marks. Power is equal to A minus 2.5 L minus 0.9 K, where P is what? Power of the IOL that you want. It will be in diopters. A is specific constant for the IOL. Some specific constant that the IOL comes with looks like. A is the axial length of the eyeball in millimeter. So you should know the eyeball length. Okay. And K is the average keratometric reading. Keratometry will give the curvature of the cornea. Very good. So can you say the formula? A minus 2.5 L minus 0.9 K. ALK. Okay. Minus 2.5 L 0.9 K. So in the exam they will ask this. Write the formula. SRK. Sanders Retzlaff Kraft formula. The formula is P is equal to A minus 2.5 L minus 0.9 K, where this is this. How will you get the axial length of the eyeball? It is determined by A scan ultrasonography. So axial length will be something like this, the length of the eyeball kind of a thing. They will get it in A scan ultrasonography. K, how will they get? From keratometry, they will get the average corneal curvature. Very good. So remember Sanders Retzlaff Kraft formula. SRK, like Shah Rukh Khan. SRK formula and ALK. What is ALK? Say what ALK is. Just remember something like this. Walk. WALK, walk. W, what is the power of the IOL? ALK. A minus 2.5 L minus 0.9 K is the power of the IOL. Okay, good. So we are done with the power. What is the next slide? Equipment for biometry. What and all you need for biometry? You need an A-scan ultrasonic biometer to calculate the axial length. Yes, we know that. Then you have optical biometers. What is this? Okay. So many biometers are there. What will you get finally? Axial length. Okay. So you know how to calculate the power now. Guys, there are two terms here. Primary IOL, secondary IOL. Primary IOL implementation means along with cataract surgery, first of all, you are giving him IOL. Let us say secondary means you have previously operated eye. There is aphakia. Now you are putting the IOL. That is secondary. Guys, in the textbook, they have given the technique to put a posterior chamber IOL, the technique to put an anterior chamber IOL. You can look at all that. Technique they did not ask, no, so we are not looking at that. Now look at this. Guess what this is? This one is anterior chamber IOL. See, it is kind of like this. Oh, this is anterior chamber. It has like S shape. Okay, then this one is Singh and Worst iris claw. Claw. Is there a claw here? This is the iris claw lens. Okay, then this one. This looks like a unifocal, simple, beautiful posterior chamber IOL. Modified C-loop. This is a modified C-loop haptic, is it? Now last one, guess what this is? This is posterior chamber IOL with 4-loop type. This we saw, something like this we saw when they want to have accommodation, right? Let's see, wait. If you remember, that accommodative thing had something like this. See, this one is inward bud. See, this is like this. But that one was like this. That accommodative one was like this. But this one is kind of inward. This is posterior chamber IOL. 4-loop. Just pay attention here. This one is kind of going outward. The accommodative type. Finally, guys, we have reached this point where we want to look at the complications which will happen because of putting an IOL. Okay. So in addition to the other complications of surgery, etc., just remember that there can be cystoid macular edema. Okay. Cystoid macular edema can be a complication. Endothelial, corneal endothelial damage. See, that is where the endothelium, right? The back side of the cornea can get damaged. See, this is the lens, right? Now here you're trying to put an intraocular lens. This is the endothelium of the cornea, the back side. So this may get damaged, okay? So it can cause infection, uveitis, inflammation of the uvea. Secondary glaucoma can be there because you're inserting something, so the pressure there can become more, is it? Secondary glaucoma. So all these are seen, especially anterior chamber and iris supported IOLs will have more problem. Posterior chamber will have little less problem, looks like. UG-H syndrome refers to concurrent occurrence of uveitis, glaucoma and hyphema. So if they ask you what is UG-H syndrome, remember uveitis, glaucoma, hyphema. Hyphema is blood in anterior chamber. All the three together if they are UG-H syndrome. What is UG-H syndrome? Uveitis, G is glaucoma, H is hyphema. Okay, very good. This was common with rigid anterior chamber, which nowadays they don't use. What do they use now? Foldable, rollable? Yes. We are looking at all the problems that can happen. There can be malpositions of IOL like decentration, subluxation, so many things. There are fancy names they are saying like sunset syndrome where the inferior subluxation happens, sunrise syndrome where the superior subluxation happens, lost lens. It is complete dislocation of the IOL. It goes off into the vitreous cavity. Windshield wiper syndrome occurs very small IOL if it is placed vertically in the sulcus. Whenever that guy moves his head, superior loop moves left and right. So that will be like windshield wiper syndrome. Look at this, guys. Decentered IOL. Definitely we can see the IOL here, right? That is the margin, looks like. Decentered IOL. It went off from the center. Look at this one, subluxated. Subluxated means partially dislocated from its position. What is this one? Sperophakia. Forward subluxation of the lens in some syndrome. So it has come off in front, forward subluxation, is it? Okay. So what are the malpositions, guys? Sunset, sunrise, lost lens, windshield wiper. So many terminologies are there here. Pupillary capture of the IOL may occur. Okay. Toxic some anterior segment syndrome. Last, just few things left. Let us look at the instruments that they need for intraocular lens implantation. So there is some IOL holding forceps. This is some forceps to hold the IOL. This is another IOL forceps, looks like Kelman McPherson forceps. Then this one is Sinskey hook or IOL dialer. IOL dialer. It is used to dial the PMMA non-foldable IOL for proper positioning. Really the last slide, guys. Piggyback IOL. Add-on IOL. Okay. One IOL will be in the capsular bag and the other will be in the ciliary sulcus. Let us take a quick recap of this video on intraocular lens or IOL. So basically it's a method of choice for correcting aphakia. They will implant an intraocular lens. So it was first done in 1949 by Harold Ridley, British ophthalmologist. If you have to correct aphakia, you will have to give very thick glasses that can cause magnification of the object, anisometropia, aberrations, prismatic effect, etc. So they are giving an intraocular lens so that the person will not have all these and they will have better and wider field of vision, cosmetically more acceptable, and there will be no magnification of the object. Once an artificial lens is put, what will it be called as? Pseudophakia. Refractive position of the pseudophakic eye, usually you'll try to make it emmetrope. Weight of an IOL in the air is 15 milligram, but when you put it in aqueous humor, it will just become 5 milligram. What is the power? In the air, it will be very high, but in the aqueous humor, it will become just plus 20 diopter. Very close to our crystalline lens. Indication for IOL implantation, each and every case of cataract, unless contraindicated. So cataract, the lens got opacified, so remove the crystalline natural lens and put an IOL. Types of intraocular lens you have based on method of fixation. You have anterior IOL, also angle supported IOL, they're calling it, not used much. Kelman. Iris supported lens, Singh and Worst iris claw lens, posterior chamber lens. This is anterior chamber lens, not much used. Anterior chamber lens will have little less power than posterior chamber lens. Iris supported lens also not very popular. Then you have posterior chamber lens, which will be, it can be in the capsular bag, which is common, and this is also called as PCIOL, posterior chamber intraocular lens. Okay, so PCIOL. So this is the most ideal method. You put it in the capsule of the lens, right? And you have otherwise you have ciliary sulcus fixation, scleral fixation, or you also have another one called as retro iris fixation. So this one is an anterior chamber IOL, Kelman, and this one is Singh and Worst iris claw lens. This is posterior chamber IOL, modified C loop, and this one is posterior chamber itself, quadri loop type. See this like this, okay, quadri loop. Based on the material, you have IOLs like rigid IOL, foldable IOL, and rollable. Three things. Rigid is made up of PMMA. Foldable will be going through an incision of 3 millimeter. It will be made up of silicone and acrylic. Rollable will be ultra thin. This will be made up of hydrogel. It has to go through 1 millimeter of incision. Example in micro incision cataract surgery. Remember, PMMA means polymethyl methacrylate. Polymethyl methacrylate. Okay. Next. Based on the focusing ability, you have unifocals like this one, or you have multifocals like this one for near vision and distance vision. Then you have this one, which is accommodative IOL. Okay. So it has some loop. This is accommodative. So aphakic lens means you don't have a lens, so you're putting a lens. But what is phakic refractive IOLs? That means if a person has myopia of greater than 8 diopters, they're considering putting a IOL. Then you have special function IOLs like Toric IOLs. Toric is for astigmatism, to correct astigmatism. You have aspheric IOLs to reduce spherical aberrations. Aniridia IOLs to cover the defects of aniridia. So this one is showing a toric IOL, and this one is showing an Aniridia IOL. See, it kind of shows an iris. It's showing just cosmetic purpose. Okay. So we are still looking at the types of IOL. There is something called as primary versus secondary IOL implantations. Primary means in cataract surgery, then you remove the lens, then you put IOL, that is primary implantation. Secondary is after operation there is aphakia, then again you are implanting a IOL, that is secondary IOL implantation. Piggyback IOL means there are two IOLs, one in the capsular bag and the other could be in the ciliary sulcus. Now we have to calculate the power of posterior chamber IOL, posterior chamber PCIOL. How will you calculate? Posterior chamber IOL's power is equal to ALK. A minus 2.5 L minus 0.9 K. ALK, like walk. WALK, PALK. What is the power of the posterior chamber IOL? It is A minus 2.5 L minus 0.9 K. So what is in this P? P is the power of the IOL that you will put. A is the specific constant of the IOL. There will be an IOL constant that it comes with. L is what? L is the axial length of the eyeball. You will measure this with what? Biometry. Many methods are there, but you can use A scan, ultrasound, etc. Then 0.9 K. What is K? Keratometric reading. That is the curvature of the cornea. Okay, so this is called as SRK formula. What is this formula called as? SRK formula. This is a surgical technique on how to put an anterior chamber IOL, guys. So you can see an anterior chamber IOL here. Then similarly, they will explain how to put posterior chamber IOL. You can see all that. Then you have instruments which are used. You have this IOL holding forceps, Kelman some forceps, IOL dialer. Finally, let us look at the complications of IOL, cystoid macular edema, UGH syndrome, that is uveitis, glaucoma, hyphema all together if it is there, UGH syndrome. So basically what and all these people, they can also have corneal endothelial damage, right? Then malpositions of IOL, there can be inferior subluxation, which is called a sunset syndrome, superior subluxation, which is called a sunrise syndrome, lost lens syndrome, where there is complete dislocation. Complete dislocation is called as lost lens syndrome. If it is partial, that time they are using the word subluxation. Windshield wiper syndrome, where whenever the movement of head, the superior loop moves left and right, looks like. Okay, windshield wiper syndrome, like the wiper of the car, right? Windshield. There can be pupillary capture of the IOL, toxic anterior segment syndrome. So that's it, guys. We are done with this revision also of intraocular lens. Okay, that's all for now, guys. We'll meet you in the next video. Bye bye.